And welcome everybody back to another episode of Webinar Wednesday. A very, very timely topic that we're covering today, as you will see as we walk through our presentation. I want to start with this whole idea of what it means to be a contrarian. Now, my definition of being a contrarian is rejecting popular beliefs in favor of your own beliefs. Now, history in the world of business is full of people who have done this to great success. I think back to the story we've all heard about Fred Smith, whose idea for Federal Express was poo-pooed by his teachers his professors when he was going through business school. And we all know what a success that FedEx has become. Think about Jeff Bezos and Amazon, and many people believe that his idea for creating the electronic superstore that he did was a crazy idea. Same can be said of Elon Musk at both Tesla and SpaceX, and how many people didn't believe that he would be able to do what he did. Not too long ago, I read the biography about Steve Jobs. Now, Steve was a really, really strange person, but the truth of the matter is his contrarian thinking totally revolutionized not just the world of personal computing, but the way in which so many of us communicate across the globe. Now, I'm no Steve Jobs or Elon Musk, but in my own way, I like to think of myself as a bit of a contrarian. I like buying houses, for example, that nobody else wants and finding a way to turn them into something that other people would love to live in. I did the same thing in my manufacturing days, finding manufacturing companies that maybe needed a little polishing up or weren't quite on the outside what they were on the inside, and acquired those companies and turned them into something bigger and better. So in this whole idea of electronics, we are contrarians here as well. Electronics engineering is that branch of electrical engineering that works with things like electronic devices and integrated circuits and transistors. We'll talk about that today. Well, conventional wisdom is that these careers aren't necessarily going to grow. According to the Bureau of Labor Statistics, overall employment of electrical and electronics engineers is only going to grow about 3% between now and the end of the decade. This sentiment is echoed by Ohio University, which says that while some fields are growing fast, electrical engineering job growth between the years of 2018 and 2028 will be modest. Well, maybe they're right, but maybe they're not. Let's talk for a moment about this whole world of semiconductors. Now, semiconductors, if you're not familiar with that technology, that can be as simple as a diode or as complex as an integrated circuit or IC chip that we see on the circuit board on your screen, processing complex mathematical and data information in real time. Without these pieces of technology, we wouldn't have mobile phones or personal computers or digital cameras or automobile electronics. We wouldn't have things like solar cells without semiconductors or routers or televisions or LED bulbs. In fact, in the United States, 12% of our gross domestic product, according to the Wall Street Journal, relies on semiconductor technology. This is the crude oil of the information age, as the founder of Advanced Micro Devices said. What's interesting is that Jerry Sanders made that statement in the 1970s. And boy, was he right about that. So you'd have to be living under a rock not to realize all of the attention that is coming to the world of semiconductors. As we see in ZMZ Science, the semiconductor crisis is now affecting car manufacturers. The Hill tells us why we should care about the chip crisis. Intel and TSM anticipate the crisis to extend beyond 2021 by some estimates into 2023. And the long-term costs of the shortcuts in the economic times in the semiconductor crisis is dire. Semiconductor chip crisis extends to washing machines and toasters, and as we talked about, just about every element of our economy. So here's the thing. When we talk about chip making, there are two companies that usually come to mind. Taiwan's TSMC, that is the Taiwan Semiconductor Manufacturing Company, and Samsung Electronics, which together account for more than 70% of the semiconductor market. That's why this article that showed up yesterday in Defense One is so concerning about when or when not China might attack Taiwan, given Taiwan's huge position in the world of semiconductors. All of this is coming back to a discussion around reshoring of this technology. Now, I spent some time last year in a presentation to Tsinghua University in Beijing. It was fascinating. Several thousand people, believe it or not, attended that virtual presentation on smart automation technology that we provided. Now, here's what the director of the Institute of Microelectronics at Tsinghua University says about the supply chain for semiconductors. He says chips are designed in the United States, processed in Taiwan, packaged in Malaysia, and finally sent to China for production and distribution worldwide, much of that distribution back to the United States. So think about how convoluted that supply chain is. And that's why if we continue this article from CNBC.com about this whole world of chip making, it says the US, which was once a leader, by the way, in this technology, lags behind now after monumental shifts in the business models in the semiconductor industry. But a global semiconductor shortage and geopolitical tensions with China are bolstering Washington's scrutiny of the supply chain and has created a drive to bring manufacturing of this technology back to American soil to regain leadership. The U.S. has earmarked billions of dollars and is reportedly looking at alliances with other nations. Now, I don't know if you saw this news this morning. Melissa and I were marveling earlier today. It might not surprise you that we have our schedule for Webinar Wednesday, typically scheduled several weeks, if not months, in advance. And this whole technology of semiconductors is on the tip of everybody's tongue today. It was announced this morning that the Semiconductors in America Coalition was created yesterday. Now, this is no small group. It boasts members and founders like Intel and NVIDIA and Qualcomm, AWS, Apple, AT&T, and so on. And what this organization is doing is it's put together a coalition to push for tens of billions of dollars in federal funding for semiconductor research and manufacturing in the United States, according to the New York Times. So our contrarian prediction because of all this is this: efforts to reshore electronic supply chains back to the United States will drive demand for electrical and electronics engineers and technicians to much higher levels than conventionally predicted, much higher levels that was predicted just a moment ago in some of those quotes that we put up for you about the demand for electrical and electronics technicians and engineers. We'll see if we're right, but we think we are. Here to talk with us about this fascinating topic are two great guests. The first guest is my friend Chris Rowe. Now, I first met Chris in the fall of 2015 at a conference here in the United States, and then he and I met again, and he'll remember this, in the restaurant of the Sloane Square Hotel in London, England, where we started to piece together the relationship that our two companies have together today. Chris has a phenomenal background. He studied electronics in the mid-1970s, was one of the founders of LJ Electronics Limited, which later became LJ Create in the year 2002. And he has worked for this UK-based company for 41 years, 16 of which, he's no stranger to the United States, 16 of which were in the USA, before returning to Norwich in the year 2000 to manage the company's product development. Now he is in the role of managing director of this company, LJ Create, which employs a wide range of highly qualified staff in the fields of science and mathematics, software programming, and electronics. It's great to have Chris here. Also with Chris is another great friend of ours, Andrew Gillies. And Andrew works in product management for LJ Create. He finds himself at the intersection of tech ed and ed tech. He develops technical education solutions for schools and colleges. And previously, he has been a teacher. He's taught electronics, and he introduced and led new electronics programs at the high school level. Before entering the world of education, Andrew worked as a control systems engineer, and he has a degree in mechanical engineering. It is awesome to have both Chris Rowe and Andrew Gillies with us this afternoon. And Chris, I'm going to begin with you, and I want to ask you this question. Do you see the supply chain transformation and issues in the UK the same way that we do here in the United States?
Uh, I I guess so. Yeah, I don't run a business in the United States, so I don't know how it would be there, to be frank. Um, across Europe, we see the situation in possibly a slightly worse dimension than that you see in the United States, because although the two largest manufacturers of semiconductor devices are in the East, you do at least manufacture semiconductor devices still in the United States, and you have Intel in particular who generates semiconductors. The other issue is most of your major manufacturers will have orders for semiconductor devices with the manufacturers that stretch over decades, and so would be more value to customers probably than the smaller manufacturers here in the UK. So yeah, we are seeing substantial difficulties in certain industries. Just like you guys, automobile manufacturing has been severely hit by this. There are, as you've indicated, the same sort of negotiations that are going on in the US are happening here in Europe. The European Union is negotiating with Intel to partner with them to build a very large semiconductor manufacturing plant somewhere in Europe. To this point, Intel and Intel's partners are asking for around $8 million of investment to get that done. And of course, the issue at the moment is where is a figure like that going to come from? In terms of our own business, we're a relatively small manufacturer. And we don't order specific processors specific to our products. We tend to buy generic processors and then program them ourselves. What that means is that does give us a little bit of supply chain guarantee, and that is that with a bit of development effort on our part, when the stock of a processor runs very low and we find we can't get it, we can select another processor and put our programs into a slightly different processor. So we are able to skip from device to device. Having said that, we have and are experiencing delays and substantial price increases in semiconductor and other components. Part of that, of course, is it's not just the semiconductor supply chain, transportation logistics, the cost for transportation over the last year, given the events of the last year, are just sky high. So, for example, last week we attempted to ship products, a substantial package of products into the Midwest. A TEU, a 20-foot container from the UK to the Midwest, where they were asking for $8,500 to ship that just a couple of weeks ago. And that would normally cost around about $3,000. So transportation costs are extraordinarily high at the moment, which of course has a dramatic impact on the supply chain. I spend quite a lot of time, particularly over the last year when international travel has been an issue. I spend quite a lot of time traveling around the UK and chatting to people in the UK, both educational establishments. Here it would be colleges of further education, those folks who are training technician level staff, and also universities that are training electronics engineers, and also meeting with industrial clients. These are usually clients who are making use of our online database of learning materials to retrain or upskill their employees. They've pointed out a few issues that have come from the supply chain issues over the last 12 months, um, it's worth bearing in mind that there's not just a generic international shortage of semiconductor devices. What's happened is as the demand for very smart devices, those top of the range devices, which are extremely profitable and are used in mobile phones or smart televisions or computer systems, as the demand for those rapidly outstripped the supply last year, the manufacturers of semiconductor devices switched plants very quickly over to making the much more profitable top of the range semiconductor devices. So those industries that have been most impacted by it are actually the industries that use the kind of second rung of semiconductor devices. That is, those that require quite sophisticated manufacturing, but are older and are much less profitable for the semiconductor companies. So, for example, there'd be maybe 20, typically there'd be perhaps 20 of those processors used inside an automobile, and those are not usually top of the range semiconductor chips. So it's those that have a substantial issue because the lines to produce them simply don't exist anymore. Those older production lines have been disassembled and replaced with more advanced production lines. So what does that mean for our clients? Basically what it means is, and we're seeing this quite a bit now, is that where typically a production line is kept in good shape by the removal and replacement of subassemblies. Let's say, for example, flat panel monitors that are used as part of a control facility. Maybe the usual issue has been to simply rip out the monitor and replace it with a replacement part. Well, what they're finding, of course, is those replacement parts are now no longer available. And so increasingly, maintenance staff amongst our clients are actually having to take the flat panel out and try and repair the darn thing. And of course, that's requiring skills that perhaps lots of those folks don't have. And it's a real question in terms of what are we doing now in education and training to prepare another generation of electronics technicians and electronics engineers that are perhaps more capable at that component level diagnostics.
Which I think is a great, if I may, a great transition into the second question that we had for you, Chris, which is on this whole topic of electronics talent. And I know that LJ Create is, as you suggest, an electronics manufacturer, in addition to a company that is obviously well ingrained in the supply chain of electronics. Are you experiencing the same shortage in skilled electronics talent that we're seeing across the globe?
Yeah, we absolutely are. What we're finding predominantly now is training both at technician and engineering level has been very focused on programming of embedded devices. So it's very, very straightforward for us to find programmers at all of the various levels of programming skills required. What we're finding much more difficult is to find those engineers who can actually interface and connect devices into those embedded devices. There are a couple, you should see on your screen some images. The top is an image from one of our circuit diagrams, and I put that up to show the large yellow blobs, which are the embedded devices, but everything else on that board is pretty well a fairly passive device and requires knowledge of electronics theory and practice in terms of designing those circuits that, frankly, the university students that we've seen over the last 10 years haven't really had. And then there's the other issue, and that is attitude, of course, of employees. I just wanted to say a word about this. The other two pictures, I bring this up because of the other two pictures there, and that is we employ lots of electronic specialists. We employ some quite highly paid electronic specialists. They're experts in their field, and yet we're a small company. And so when the need arises, and here are two of our staff in Oman, at that time it was 52 degrees centigrade, which Fahrenheit, I don't know, is maybe 125. And there they are unloading 7 container loads of products that we ship there, and they've got to get it out of the containers and into the classrooms before they can start installing and doing some of the sophisticated work for which they've been trained. And my point here is, when you work for a small company, it's all about attitude, and students need to know that as well. Young people, as they're joining us, they want to be given a job, and they'll fret if what they're being asked to do strays beyond that job description. For example, wandering about in 125-degree heat with pallet loads of equipment. Anyway, thank you very much, Matt.
Well, thank you, Chris. It's been a pleasure having you on thus far. And speaking of 125-degree heat, we have all the way from Houston, Texas, perhaps not quite 125 degrees, but much balmier, I'm sure, than in the UK, and certainly than where I am in Wisconsin, is my friend Andrew Gillies. And Andrew, we want to welcome you to Webinar Wednesday. And I want to walk through a couple of questions around how we teach this electronics technology at every level of education, from middle school all the way through our four-year universities. So if you would, a minute or two on each of these topics, how would you say, Andrew, that we should teach basic electronics schools and give our students the tools they need to be successful in an ultimate career of electronics, or at least put them on that journey? How should we do that in middle school?
Okay. I've had a lot of experience in middle school, and we've been working a lot in middle school. And at the start of middle school, when students have learned in elementary, they know a little about conductors and insulators and properties of materials. They know about energy a little, and they know that a simple circuit consists of a battery and a switch and a lamp. In middle school, they don't, in the science curriculum of most states, they don't develop that a huge amount. They don't get into components, but they just look at the atomic structure and energy again, and that's where the electronics part is done. Electricity and electronics is usually part of an elective STEM program or the CTE program, and that's where it's looked at. And most times now it's a systems-based approach. So it might be using some kind of STEM kit or a simulation or plugging sensors in and building some kind of robotic device. Sometimes some schools do breadboarding and PCB design a little bit more so with Makerspace. But the problem that we found in middle school with electronics programs is that the students don't have the basic understanding of the real simple things: a volt, a current, resistance, and how to use a multimeter. So what we've done is put in introductory programs into our middle school for teaching the students basic electrical measurement. What is a volt? What is current? What is resistance? To a deep, understandable level, so that they can apply that through their future career. And from my point of view, that's the core thing that they should come out of from moving from middle school to high school.
So a great understanding of Ohm's law, a great understanding of the basis of electronics and electrical technology, taught, as I know you're a huge advocate of, in a great hands-on, engaging way. Is it's really about trying to grab the interest of these young people and inspire them toward careers in STEM. And I know that's a passion of yours, Andrew, as it is for me, as they continue through that middle school pathway and on to high school. Let's talk a bit about those competencies that we need to deliver at the high school level, and what they should be learning around electronics as they go through their secondary education experience.
Mm-hmm. Yeah, so again, in physics and physical science, the students will get into more depth about learning about electricity, the science concepts such as fields, and the definitions that underpin it. So they will be learning about volts and amps and resistance and serial and parallel circuits, but maybe they're doing it a little bit late, perhaps, in terms of what they're trying to do. So again, electricity and electronics becomes part of the STEM cluster, the career clusters, and some in Texas, for example, they have a whole pathway that will take students all the way through to high school to be electronics engineers, electronics technicians. So they start off with AC and DC, and they look at digital and then solid state. So the things that we really want to get into the basics of in high school are basic DC theory again. Can't emphasize how important it is to understand the volts, the amps, the current, the resistance, and using test equipment, measuring voltage, resistant current. And then also introducing students to AC and bringing in oscilloscope use and signals, being able to look at signals, the differences between analog and digital. And then in high school, we'll also start using real systems and looking at specific electronic applications in things like construction with alarm systems and automotive, obviously we've talked about. And then another thing that if we're going down a technical skills pathway, some experience of soldering and wiring and connecting up things. Most of the kits and the STEM kits that people use, they're just plug and play. And at this point, what we're finding is this, when they get into these high school mechanical technician programs, they really need some experience with just how to connect wires and wire things up and make connections to sockets and using tools. So that's an important thing. And then the whole idea of interfacing electronic systems. And then if we're in the makerspace space, we can do PCB and design stuff as well. But that's hard to do with the that depends a lot on the level of the teacher. But for high school, electronics is really a great platform for integrated STEM because it's got the physics, it's got the math concepts, it's all about engineering, and we're designing technological solutions using engineering. It's just one of the best for integrated STEM. And then once we get up into the career center and the community college, we're getting much more into real systems and real concepts and looking at power supplies and how the power supplies work, multiplexing, bus systems, signal interfacing and digital and analog conversion, and all those applications across different sectors. So cars, motor vehicles, for example, are filled with bus systems and data is carried around the car. And so students need to understand that. And then they get into using high-level skills, setting up and configuring things like PLCs, drives, transducers, process control. But again, the fundamentals of all that stuff is being able to understand what volts is, what current is, and using a multimeter and an oscilloscope. So that's the, again, I keep coming back to that. That's the core thing. And then the other thing that we see a lot is the students of the integration between the different systems. The manufacturers want students to be able to integrate systems from different manufacturers.
Absolutely. So that integration is so very important. I love the way that you talk really about that whole portfolio of skills, Andrew, both in high schools and in our technical and community colleges, for that matter, our career centers, making sure that we do understand the basics of Ohm's law, for example. Your observations on things like soldering and wiring and actually doing the hands-on skill, that's very important as well. And I think it reflects well and engages the students in a real positive way also.
Yeah.
So great, just a great suite of skills that these students can come either out of a high school program, a technical or community college program. Also, as we look to roles like electronics engineer, electrical engineer, where maybe they're going on and earning full bachelor's degree or even master's degree credentials in the field of electronics and electrical engineering. What are those skills that employers are looking for, in your view, for a student coming from a four-year university electrical or electronics engineering program?
From an employability, from an employability point of view, obviously students in four-year degrees get much deeper into the mathematical theoretical analysis of how components work and the engineering design principles. So rather than looking at a filter and saying this is a filter and we can change these components to get a different result, they actually understand Fourier analysis and the design optimization and can design new filters. And then they're going to be the folks that are going to do this piece, the design of these new chips, which is obviously all computerized now, but they're going to be the guys that are going to design these new integrated circuits and new applications. But from a university straight into industry, we can see these guys in the image. They need to be active doing real application work later on in their, the second 2 years of their college degrees. And I know some college degrees are now including certifications, industrial high-level certifications as part of the college degree. So
And that was one of the
which
questions I had for you, was to, before we turn it over to Melissa and see what questions are rolling in from the audience, I did want you, Andrew, to touch briefly on what certifications you see as important or potential ones that our educators should be thinking about as they build their programs. What third-party credentials are out there?
Yeah, absolutely. For electronic technicians specifically, there's an organization called the Electronics Technician Association International, and that's a certification body, and those certifications are count towards your Perkins funding and all those kind of things. And they do different levels of certification. So they do a student certification in a basic electrical DC certification, which the students can do at high school, and we have programs where students do that. And then they do more specific industry focused certification. So you in a range of sectors. So for example, you AV and electronics or telecommunications. And then they do an industrial electronics technician certification, which has been designed with industry and community colleges. And they learn about, again, PLCs, network systems, robotics, and the integration and interfacing of all those things. And then, of course, electronics is a huge part of other certifications which aren't specifically electronics. So ASE, the automotive certification packages, electronics is a huge part of that. The maintenance technician level certifications, logistics. You know, I mean, I don't say it lightly, but literally every technological application has electronics into it. So any technological certification pathway is probably going to have an element of electronics in it.
Absolutely. Well, so certainly a great number of certifications that our educators should be thinking about as they plan for the future of their programs. Obviously, those credentials and certifications so very valuable oftentimes as those students move on to the workforce, and ensure that they have the skills and the competencies, the experience, the knowledge that the employers are looking for as students transition from education into the workforce. So Melissa, with that, I'm sure we've had some interesting questions roll in for Chris and for Andrew over the course of our discussion today. What are you seeing from the audience, and what would they like to talk about?
Yeah, absolutely. And again, to our audience members, go ahead and submit your questions using that Q&A button. Andrew, I'm wondering if you could tell us, just give us some specific examples of the types of companies that these students, whether they're coming out of a 2-year program or a career center, or they're coming out of a university, what are the types of employers that they'd be working for?
With electronics engineers, I mean, an electronics qualification, an electronics technician qualification, or an electronics degree is going to open you up to a whole world of possibilities. As I've already said, you've got all of the industry maintenance, you've got industrial technology, automotive, autonomous cars, all that kind of new developments, robotics. And then obviously companies like Texas Instruments, National Semiconductors, Intel are obviously going to be wanting to hire electronics people with college degrees to do the design part and those sorts of things. So literally with an electronics degree or an electronics qualification at this point in time, I would suggest the world's pretty much your oyster.
Absolutely. Matt, I'm going to direct this question to you. Do you think that this, the shortage we're seeing and the reshoring is going to be is a temporary thing, or do you see this as a long-term change for the U.S.?
It's interesting, Melissa, as we look at the predictions, this isn't a short-term problem. Even the solutions, because of, as Chris suggested earlier, $8 billion investments in this technology to move, for instance, semiconductor manufacturing from one continent to another. And it takes time. And part of the reason that these companies, like the ones we mentioned earlier in Taiwan and in Vietnam, have such a control over that market, is because it is very expensive. It's very high tech. It's not something we can just move very quickly. And as we know, the electronics market is ubiquitous. Everything that we touch contains this technology. So we think it's a longer term issue. Certainly, it's an acute issue in the short term. But as more and more of that supply chain moves closer to the point of use, because we've all seen what happens when we have a supply chain that's spread out all over the globe, as that moves closer to the point of use, whether that's fulfilling demand in the UK, fulfilling demand in the United States or elsewhere, that is a long-term transition. And so we view this as a long-term problem.
Could I add
Please.
a little?
Yes, Chris.
Melissa, it's an extremely long-term problem, and the shortage is relatively long-term. What is more concerning for fairly small-scale manufacturers, or for example, the geographic region that I'm based in, I'm surrounded by food production. Now, food production tends to be relatively low profit margin, but wherever it occurs around the world. So that means these food processing plants are largely are fairly well living on the edge in terms of cash flow and profitability. Now, you imagine you're running a 25-year-old control line in a food processing. I don't know whether you're sorting potatoes or baking pies. You're running control electronics. You've got a control system that runs your factory. It's 25 years old, and now you find you can't get spare parts for that factory. What's going to be your response to that over the course of the next decade? Where does the $10 million come from in order to upgrade your potato sorting plant? Well, it's not there. And so what's going to happen for the next 10 years is people are going to be pulling themselves up by their bootstraps and trying to keep these machines running. And that's going to get increasingly difficult over the course of the next 10 years. And what they're going to need, to be honest, is old-fashioned technical staff, just as were being trained, just as were being trained in the 70s and 80s when Andrew and I did our electronics education.
It's a great answer.
Great, thanks. Matt, I'll let you wrap it up for us.
All right. Well, thank you, Melissa. Thanks to our audience for being here. I want to especially thank our guests, just fantastic guests, both Chris Rowe and Andrew Gillies from LJ Create. They're both great friends. They are, as you can tell from this discussion, very knowledgeable in the world of electronics, in the world of supply chain, in the world of business, and in the world of education. So what a pleasure to have the two of them on with us today. We have several great episodes of the Webinar Wednesday series stacked up for you in the coming weeks. Coming up a week from today, next Wednesday, we will be meeting with a gentleman from Madison College who has unbelievable capstone projects for his students in their automation and electromechanical programs. So these students that are integrating high-tech automation technology in ways that you will find hard to believe for a technical or community college. So if you are one of those employers that loves having technical talent that comes job ready, understands how to integrate technology, if you are an educator that is trying to figure out how to do that in your program, you won't want to miss next week's Webinar Wednesday. Really appreciate everybody being here. We do this every Wednesday at 2 o'clock, and we will see you all next week.